That brings me to step 4, which is creating the adjugate matrix. It's not really a lot of work to be done here. This step isn't that difficult. You just take what's called the transpose of the cofactor matrix. So this is the cofactor matrix that I found back in step 2 after I took my matrix from step 1, applied the sign matrix to it to create this cofactor matrix. Now, what is a transpose, you might ask? Well, what the transpose does is it just switches the rows and the columns. So the first row of this matrix, which is -8, -10, and 4, becomes the first column of this matrix. So -8, -10, and 4. The second row of this matrix just becomes the second column of this matrix. So -7, -10, and 4. Again, this row just became this column. And now finally, the third row of 4, 6, and -2 just becomes the third column. So I have 4, 6, and -2 in my third column. So this is the transpose of the cofactor matrix, which is known as the adjugate matrix. There's a lot of vocabulary being thrown around here, but no one thing that I've done has really been that difficult. Just a lot of places to make mistakes. We're finally in the home stretch. We just have to do a bit of scalar multiplication and then we're done. So to find A inverse, we have to take this adjugate matrix that we just created in step 4, and we have to multiply it by the scalar 1 divided by the determinant of A. Back in step 3, I figured out what the determinant of A was. The determinant of A was 2, if you recall. So I'm going to go ahead and put that right here. So I have 1 divided by the determinant of A. Okay, so now I'm going to go ahead and go through this, and I'm going to put this in to the final answer now, the inverse of this matrix. I need to multiply this scalar of 1/2 times all of these entries in this matrix to create A inverse. So A inverse is equal to this new matrix. 1/2 times -8 is -4. 1/2 times -7 is -7/2. Again, I'm going to put that in as a fraction whenever I set up the answer key. It is -3.5. I will accept that as an answer, but I think the computer is going to mark it wrong. So if you want the most accurate feedback from our computer system that we're using, put it in like this, -7/2 for any of these ones that come out as decimals, like that. 1/2 of 4 is 2. Half of -10 is -5. Half of -10 again is -5. Half of 6 is 3. Half of 4 is 2. Half of 4 again is 2. And half of -2 is -1. And finally, after what seems like 7 years of work and a whole bunch of steps, I've arrived at the inverse of this 3 by 3 matrix. And I have completed this problem, and now I can take a break.